Welcome back, everybody. We are going to work on more solving systems of linear equations. And this time we're going to take a look at substitution. So the steps to solving by substitution, we are going to solve one of the equations for either x or y. Take whatever equation we solved for the x or the y and plug that into the other equation. Once we find out what either x or y is, we take that answer and plug it back into one of either the original equations or the one that we solved for either x or y. Take a minute to pause and write down these steps. All right. So for number one, I'm looking, did we have one of these already solved where x or y is alone? And we do. This very first one is already solved for y. So what that means is we can take this whole part of the equation and put it in place of that y. So we write 6x minus 5, because none of that changes, equals negative 19. In place of the y, I'm putting 2x minus 9. Now that I've substituted that in, we get rid of the parentheses by distributing. Remember, the minus stays with the 5. We have the 6x that we bring down. Negative 5 times negative 2x is positive 10x. Negative 5 times negative 9, is positive 45. Combining like terms, 6x plus 10x is 16x. Now we can work on getting x alone. So the opposite of adding 45 is subtracting 45 from both sides. We get 16x is equal to negative 64. The opposite of multiplying x by 16 is dividing by 16. And we get x is equal to negative 4. Now that we know x is equal to negative 4, we can go back to one of our original two equations to plug negative 4 in for x. So we can plug it in here, or we can plug it in here. I'm going to choose to plug it into the top equation. So we have negative 2 times negative 4 minus 9. Negative 2 times negative 4 is positive 8. And 8 minus 9 is negative 1. So our final answer, remember we write everything in ordered pair form, is going to be negative 4, negative 1. You can always double check that the solution is correct by plugging in both the negative 4 for x in each equation and the negative 1 for y in each equation, and make sure that they work out both to being true. Looking at number 2, we have this top equation that's already solved for x. Because it's already solved for x, we can take the negative y plus 3 and plug that into the equation for x. We write all of the equation except the x. So 5x plus 3y is equal to negative 1. I'm plugging in the negative y plus 3. Distribute the 5. 5 times negative y is negative 5y. 5 times 3 is positive 15. I'm bringing down that plus 3y equals negative 1. Our like terms are going to be negative 5y and 3y. When I add them together, we get negative 2y. Start getting y alone. The opposite of adding 15 is subtracting 15 from both sides. Negative 2y is equal to negative 16. The opposite of multiplying y by negative 2 is dividing by negative 2, and we get y is equal to 8. We can take that answer of y is equal to 8 and plug it in for y in either this equation or this equation. It doesn't matter. I'm again going to use the top because that's just straight math. So we have negative y plus 3. That's negative 8 plus 3. And negative 8 plus 3 is negative 5. So our solution is negative 5, 8. You try 3 and 5. In example 6, we're still using substitution, but this time we're saying, do we have anything solved already for x or y? And in this case, we do not. It doesn't matter if we solve the top equation or the bottom equation, and it doesn't matter if we solve for x or y. So let's say I choose to solve for y on the top equation. I would get this y alone by moving that negative x. The opposite of negative x is positive x. So we're adding x on both sides, which makes this top equation y equals 3 plus x. So I can take that 3 plus x and plug it in for the y down here in the second equation. Remember, we write the equation as is, the exception of the variable that we're replacing, which is y. Bring down the 3x. There's nothing in front of this set of parentheses to change anything, so that's still a positive 3 plus x. My like terms, 3x plus 1x is 4x. To get x alone, we're going to subtract the 3 to the other side. That adds to 0. 4x is equal to negative 4. The opposite of multiplying by 4 is dividing by 4. Negative 4 divided by 4 is negative 1. Take that negative 1 and plug it in for x in either the top equation or the bottom equation. I like to go with the one where we got the variable alone because it's just straight math. So I'm plugging in the negative 1 for the x in there. That ends up to be 3 minus 1, which is 2. So this solution is negative 1, 2. For number 7, again, it doesn't matter if we get x or y alone, and it doesn't matter if we pick the top or the bottom. I usually try to pick the variable that has just a positive 1 in front of it. So we could do this bottom equation by subtracting the 2x to the other side, or we can do the top equation by adding the y over. So we get x is equal to negative 4 plus y. So we're going to take that equation and plug it in for x. That gives us 2 x plus y is equal to 4. I'm replacing that x with the negative 4 plus y that we put here when we got x alone on that top equation. I'm going to distribute the 2. 2 times negative 4 is negative 8. 2 times y is 2y. Bring down the plus y and the 4. Our like terms are 2y plus y, which is 3y. Start getting the y alone. The opposite of subtracting 8 or negative 8 is adding 8 to both sides. That adds to 0. So we have 3y is equal to 12. The opposite of multiplying by 3 is dividing by 3, and we get y is equal to 4. Now that we know y is equal to 4, I can take this 4 and plug it in for either the y on the top equation or the bottom equation. Again, it doesn't matter. I like to pick the one that we solved though. So we have x is equal to negative 4 plus y, which we found to be 4. Negative 4 plus 4 is 0. So our solution is 0, 4. You try 8 and 9, please. Have a wonderful rest of your night. We'll see you tomorrow.